I think it was 20 years ago that I met you, right, Rich? At the Days or something like that. There was something called Days. That's many, many moons ago. Well, thank you. I know we're getting close toward the end of the day. I see some folks yawning, and I don't think, but well, bear with me here. We're getting close to the end here, I think. But the good news for me is I'm not the anchor guy. Somebody else has got to take care of the last year. But I certainly appreciate the opportunity to come and talk to all of you about what NAB has been doing with the pilot gateway. So when we started working on ATSC 3.0, and again, as I alluded to a little earlier, I've been around the blocks a few times with ATSC 1.0 and with the Days platform way back then. As some of you may know, there are a lot of different groups that kind of work differently. So one of the main objectives that we had when we started down this path of actually prototyping and building a gateway that starts to implement the ATSC 3 set of specifications, even before the spec was actually finished, right? As some of you may know, the way the web works is that they actually go and build it first. Once they actually build it, and then they come back and write the spec. So they work completely opposite the way we work. And part of that is because a lot of what the web is doing is around software. So they don't worry so much about the hardware. So they have the luxury of being able to go out there and do rapid prototype. And once they can figure out something that works, they make sure that a couple of the browser or a couple of implementations out there actually works, and then they come back and start writing the standard. Say, okay, we know that this works, so let's go ahead and put it in writing so everyone else can follow. And the objective of doing that is try to improve interoperability and get to market quickly. So what we've done is we took a page out of that a little bit. So our goal, one of our goals is to, what we're going to talk about a lot through this presentation is about why we built the gateway and why we chose the path that we did. So what I'm going to do is talk a little bit about our gateway and what lessons we learned as we went, and then what are some of the major things that we need to think about now. So we know that there's a lot of folks that are actually building the hardware or the physical layer, the lower layer, but we recognize that there aren't a whole lot of people that were focusing on the upper layer of the ATSC standard. So the gateway, even though we built from the ground up, from hardware all the way up to the interactive layer, our focus was really on the upper layer. Our goal is to really try to prove out the layer, the ATSC interactive content specification to be more specific, and take a lot of those feedback and try to feed it back into the ATSC process with the goal that we can accelerate and fix a lot of the bugs, a lot of the spec issue early on, instead of waiting until we finish a spec, then a lot of the engineers are gone, move off to doing something else, and then we find issues and we come back and say, okay, where are the original authors of the specs? So that is really the primary goal of us building out this entire platform. The second thing is that we really wanted to start to work with the vendor and start to build an ecosystem. My experience has always been that we try to deploy a new technology, something like 3.0. It's not about just one aspect of it. It's not about NAB. It's not about just the broadcaster. How fast can the broadcasters move? Or how fast can the CEs or the manufacturers move? What we have to do is we have to move the entire industry, multiple industry together. And so by building this ecosystem, it makes it a lot easier to do that. And part of that ecosystem is development tools. So we roll out all these devices, but if the broadcaster have no development tools, they don't have any way of developing services for this platform, that it really it's not helpful as well. And the final piece is really the best way to show anybody what a platform can do is to actually demonstrate it. So So one of the key things for building a prototype is the fact that we can put it in front of an executive and say, look, here's how it works. Push some button, and when they see things on the screen and they actually see interactivity, what was the old cliche? What was a picture is worth 1,000 words or something like that, right? English is a second language to me, so I might get some of this stuff screwed up, but but anyway, it's always a good thing. So what we did was we went out there and we started looking around for hardware that we could actually use to build a prototype. And we settled on a chip from ST Micro. And we were looking at basically two different platforms when we went through this process. We looked at what we call a gateway, where is everything in the kitchen sink. And we also looked at what we call a dongle type, where is the bare minimum ATSC 3 receiver. So what we ended up doing was settle on basically what we call the gateway, or sometimes we call it the fat gateway. And this thing pretty much has everything that you ever want in an ATSC 3 receiver. The one thing that I didn't mention here is it also has 64 gigs of flash. And the reason we put so much flash in there is because we wanted to experiment with the concept of downloading a lot of ads that are pre-position the ads into the receiver, and we can experiment with switching ads to add insertion, what we call client-side ad insertion. It's basically where the broadcaster's application at the last second determines which ad to play, and those ads are actually locally stored in the receiver. So having something like 64 gigs of flash in there allows us to store 300 plus of ads in there, so we can experiment with different ways of doing splicing on the client. We obviously support HDR, HEVC, AC4, and you can read the rest. But the other thing that we put into this gateway is a transcoder. We weren't really sure whether how quickly the uptake on HEVC was. This is about 2.5 years ago. So we went ahead and put a transcoder in there so that we could take HEVC and transcode it to AVC. In a case where you get into the home and you got AVC devices in the home, the devices that can't support native HEVC, we wanted the ability to actually have this gateway transcoded to AVC. And so that was the purpose of that. So in addition to the hardware, we implemented the entire 34-4 or the A44 specification. We're about a week behind, actually. So what we have today in our gateway is pretty much up to date with the spec. These are some of the applications that we developed for demonstration purpose to show proof of concept. So on the left here is a basic weather application. And it is targeted based on where the user lives, where the viewer lives. So in this particular case, we put the New York City zip code in there, and it went ahead and put the weather for New York. On the right, it's our sort of basic EPG, or an electronics programming guide. And all of these applications that I have up here are written in HTML5, strictly HTML5. So nothing special here. It's basically, for those of you who have a lot of developers on your digital side, this should be very simple for them. Right? They could come over and develop these applications very quickly. We're using all the tools and all the development tools that the web guys are using today. There is absolutely nothing special here except for a couple of WebSocket calls, and that is it. Here's another couple more applications. On the left here, we actually work with MPG, News Press and Gazette, to develop what we call a news on demand. The idea here is that a broadcaster actually create a lot of content that they can't broadcast all of them during prime time. So this is an idea that we can have a whole library of this content and allow the viewer to go and pick and choose what additional storage that they would like to consume. On the right is, again, an application that we work with the A1 folks. This is an Amber Alert. This is kind of our take on an Amber Alert using HTML5. So it's a fairly basic. I still think that it's, you know, there are a lot more things we can do with it, but this is a very basic proof of concept, just to show you what it could potentially look like. On the left here is, this is what we call hyper-localization of advertising. So what we've done here is we've taken an ad and then we further localize it based on the fact that we know where the viewer lives. So as you can see here, or maybe you can't, but it basically tells you that if you're interested in this product, this is where you can go actually purchase it. And that is based on your zip code, so it's going to find the store that is closest to where you live. And on the right side is, again, is another implementation of advanced targeting, ad targeting, and that is essentially is where we take a national ad. This is a national Chevy ad, but then we further localize it to the local dealer that is right next to your to where you live. And again, this is all driven based on the zip code. So what did we learn? I mean, the whole point of this little presentation here is it's not to tell you all about the good news, but there are a lot of work that we have to do, right? What we learned is that the TV set or a set-top box, it's not like a computer. We have limited resources. In our gateway, it actually has 4 gigs of RAM, 64 gigs of flash. But we had some developers that actually treat it like a computer, and they try to load about 30 or 40 pages into the receiver before they start displaying. And surprise, surprise, it took 20 minutes before anything showed up on the screen, right? So we found very quickly that, hey, you know, while even though we have adopted W3C standard and we are as web-based as you can get, you are still limited by the platform that you're on. And that is traditionally televisions and set-top boxes. We just simply do not have the kind of resource that you have with a computer. So that is something that we have to keep in mind as we start to develop to this platform, that we are in a constrained resource environment. The other part is resource management or contentions and management. So if you think about it, at the end of the day, the TV set is a shared device. There's multiple people watching it. And the screen, there's only one screen. There's only so much that we could put on that screen at any given point. So as broadcasters, when we start to think about the kind of services that we want to develop for this platform, we have to really be conscious of this type of thing. There are a lot of resources. The remote control is another resource. The screen is a resource. The audio is a resource. And these are things that we have to do it. We have to do it right. Because if we don't, it's going to be an awful experience. The thing about 3.0 is it has a lot of tools that, done properly, we can make a really, really good experience for a viewer. But if done poorly, we can also have the opposite effect. Transmission bandwidth, this is a big one. And I'll talk a little bit about some of the things that we're doing on that front. So one of the lessons that I learned from the HBB TV folks, HBB TV is a standard in Europe, it's pretty widely deployed today, is that because the platform allows the broadcaster, each broadcaster to have their own applications. As we change channel, if you go from channel 4 to channel 5, it's going to kill the channel 4 applications and it's going to load the channel 5 applications, and vice versa. So if you can imagine a world where now you got really big applications and you change the channel, it's going to sit there for a long time before the application actually shows up. And if you're sitting there changing channel rapidly, you're going to have major issues, right? Because we just do not have the kind of, this is not the web where we have a bidirectional connection all the time, and we can tell the server, hey, I'm this device, please send me that. That's pretty much how the web works on a computer or on mobile devices, because you have the two-way communication. On broadcast, we can't always rely and guarantee on the back channel, so therefore we have to cater our services for a one-way transmission. And that means we have to find a way to make sure that even if the bandwidth is very limited, something has to work. So one of the things that we have been doing is develop what we call an application framework, a broadcast application framework, where we abstract the core broadcast capability into an application, for lack of a better word. And regardless of what channel you're on, that core set of services is abstracting the application is always running. So therefore, when you change the channel, it doesn't have to download every single thing from scratch, and that dramatically improves the timing that the application comes up. So this is one of the things that we're experimenting with. We actually have, the framework is in alpha right now, so that as we get more developers out there, we are planning to make this available to folks to experiment with. What's next? So ATSC has done a great job of defining a lot of standards from a transmission perspective. But for broadcaster, in order for the broadcaster to actually deploy this, there are a lot of things on the back end side that has not been and will probably not ever be specified by ATSC. So for example, I talked a little bit about targeting advertising. Well, how do we deploy that? All right, so we've been looking at how the cable guys have done it with like SCTE 35 or SCTE 104, depending on whether the station is getting baseband in or they're getting MPEG 2 in. Right? If they get MPEG, we'll do 35. If they get baseband, probably 104. Well, the idea is, where do you put all the markers into your stream as it flows through the station, and how does that get integrated with your automation system? And every one of you probably have potentially a different automation system. And then how does that go all the way down the pipe until you actually wrap it in the application, it gets triggered, and then the application that's running in the receiver actually say, hey, I'm expecting a replacement to come up within 5 seconds. You know, so that whole chain today is not defined, not for broadcasters. It is defined for cable because they do it up in the head end, but for us as broadcasters, that's not defined. So that's one of the things that we are working on, just trying to experiment with what are the technology out there, what are the standards out there that will allow us to build a complete end-to-end system that we can actually experiment with and prove it out. We need a lot more receivers, right? And when I say receivers, I don't literally mean just the TV set. I mean receivers that have the interactive content, the entire stack, vertical stack. So I know that we have started deploying, or that they have started deploying in Korea, the TV set, but we need more receivers that implements the interactive content. And the reason for that is because we need to provide interoperability. The last thing there is test plans and test suite. I know I keep talking about this. I mean, I think every chance I get, I say we gotta do this, because how many of you have seen where you got two browsers, you go to the same website and they behave differently? Yeah, exactly. And we're gonna, yes.
The same document you hit print on browser A, take that same document, print on browser B, it's not consistent.
Exactly. So we're going to have the same problem here if we don't do sufficient amount of testing. All I can say is test, 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 and test some more. And we really do need to get going on that. Believe it or not, that was my last slide. I'm hoping that I have some questions. However, that this has actually, it was intriguing for some of you, but I'm open to questions.
Having heard some of the targeted advertising speeches from a rather large broadcast conglomerate based within 75 miles of here, won't name their name, but we know who they are. The idea is, how do you push, like say a large market with 25 counties, say Atlanta, push that amount into a receiver, or is it all pulled in the backbone, the internet backbone, where they already know where you are, or Comcast cable already knows where you are. Because when you call up a Google map, hey, it's right there. We're within 5 miles, usually.
Right. So I think the answer is all the above, or the combination of. So in this model, and there's a way we can test this too. If I know I have a pretty good broadband connection, I can do some polling. So not everything has to be pushed. The push model is really sort of a safety net where you don't have broadband or it's not reliable. So therefore, you want to pre-position the assets in advance so that it's in there. But remember, if the asset is not there, you play the normal one, you play the default one. So there's always an ad no matter what. But yeah, I think it's a combination of both. So the way the ATSC 3 has specified and the way we implemented is that it's up to the broadcaster application to basically figure out how to get all the appropriate asset in time before the insertion starts. So if you got to go pull it from broadband, you go pull it from broadband. If it's in the cache, you pull it from the cache. But it's the broadcast application that resolve all of these assets, and then it just tells the player go and play, and then it plays. Okay.
Yeah, just a quick question, because I get it all the time, so I think it may be something that you can explain to everybody for us. How would you characterize the difference between an ATSC 3.0 app and a widget, if you will, like a Hulu app or whatever you might find on a typical smart TV or whatever? So I hear a lot of confusion about the quote-unquote TV app. I was wondering if you could explain to people a little bit about that.
Sure. So the way I understand widget ads, at least in most cases, the widgets are typically either written natively to that particular platform or is semi-native to that particular platform. It's not a portable applications. In ATSC 3 applications, the way it is designed now is our goal is that a single application will run on any ATSC 3 compliant receiver. So the idea is to use the ATSC interactive environment as an abstraction layer. So the better way a good way to explain this is your browser, right? It doesn't matter whether you're on a Mac, you're on a Linux machine, you're on anything. When it is interoperable, you type www.cnn.com. That's actually an app, and it works regardless of the machine, regardless of the browser. And that's really what we're trying to achieve with ATSC 3.0. It's the fact that the broadcaster can write an application one time and run on multitude manufacturers' receivers. Does that make sense?
Maybe one last question. Everything you're talking about here leads me to wonder, why can't I go to my computer, go to atsc3.com and ask for WCBS in New York and get everything on my laptop that you're transmitting, of course, based on zip code?
Well, so there's a technology and then there's a business aspect to that question.
Nielsen could count them.
I can only answer the technology side. I can't address the business side. From a technology side, you can certainly implement ATSC 3 in a PC.
Excellent.
With the appropriate hardware. So, all right. Well, thank you very much.